Let's look first at one of the most important category of programming constructs, performing operations conditionally. The simplest of these is the if statement with only a single set of options. You supply a condition like x is less than 7, d is equal to 9. If the condition is true, then all of the statements inside of the if block are executed. If the condition is false, then none of them are. The second simplest version is with two sets of options. You supply a condition like x is greater than 7 or d is not equal to 9. If the condition is true, then the first set of statements is executed. If the condition is false, the second set, the set inside the else block, is executed. Now, we'll give an example shortly to illustrate that JavaScript has a kind of a funny definition of what false means. Okay, if you test x is less than 7, it's obvious. It's either true or false. But there's some other definitions of what JavaScript considers to be false, and we'll give an example of that later. Okay, and then you can have more than two sets of options by nesting if statements. So you test the first condition. If it's true, then you do the first body. If it's false, then you test a second condition. And if that's false, you test a third condition. And then typically at the end, you have an else to capture anything after that. OK, inside of the parentheses of the if is a test. And in the test, you can have some Boolean operators, like you can compare for equality. But you don't use an equals sign for equality. You use a double equal sign. Use the equal sign for assignment. Var x equals 7. Assign 7 to x. Use the double equal sign for comparison. X equals 7. You put that in parentheses of an if statement. If x is equal to 7, equals, then do this. The exclamation point means not. So this means not equals. The triple equal sign is not used all that often, but it has to do with comparing to whether two objects are the same object in memory. So with numbers, there's kind of no distinction. X equals 7 with doubles equals or triple equal means the same thing. But when we get to objects later, and with arrays, we'll see that double equals and triple equals don't always have the same meaning. And this is a little obscure. It's not used frequently. Most of the time use double equals. But when we get to objects, we'll see that you can compare not if two objects just have the same values, but if they're the same object in memory. Again, we don't really understand that now. We will later when we get to objects. OK, then for comparing to numbers, there's kind of the normal things, less than or equal, greater than equal, and they're pretty obvious, and they have to do with numbers. A double ampersand and a double vertical bar mean and or. But the important thing is that they do short circuit evaluation. Short circuit evaluation means JavaScript stops checking once it knows the answer, and it always goes left to right. For example, if you say if A ampersand B, where A and B are conditions. If A is false, then the result of the whole and is going to be false regardless of what B is, so JavaScript never checks. So if you say if blah ampersand foo, if blah is false, it never checks foo. If you use an or, then if the first one is true, it knows the whole thing is going to be true, and it never checks the second one. So if you say if A or vertical bar B, if A is true, it never checks B. And finally, you can stick an exclamation point in front of any other condition, and it flips the value. If the value is true, it's now false. If the value is false, it's now true. I'll give examples interactively of all of these later, but this is a good summary to come back to and refer to later. OK, so here's a quick example. Again, we'll run this interactively momentarily, but a quick bit of explanation. Math.random is a function. We'll see that shortly and explain it in a little bit more detail, that returns a decimal number between 0 and 1. And if the random number generator inside JavaScript is good, it returns it at random. In other words, any value between 0 and 1 is equally likely every time you call math.random. So that means that 50% of the time, it should be less than 0.5, and 50% of the time, it should be greater than or equal to 0.5. So this entire thing, half the time, it should return heads, and half the time, it should return tails. Here's another example where I make a function where I pass in two numbers, and it returns the larger of the two numbers. So if the first one is greater than or equal to the second one, it returns it. Otherwise, it returns the second one. Again, I'll give interactive examples of these shortly, but before I do that, I want to quickly summarize an example of the switch statement. So the switch statement is just a shorthand way of doing a long nested if-then-else construct. And so the idea is, with switch, you supply a value that's a number. And then you have a bunch of case statements. So this is basically saying, if day number is equal to 0, do all this stuff. If it's equal to 1, do all this stuff. If it's equal to 2, do all this stuff, and so forth. And finally, if it wasn't equal to anything that you checked earlier, give it a default value. So switch statements are pretty straightforward and obvious, except that you need to do this funny break at the end. And the reason is that if you don't do the break, it will continue checking even after it finds a match. And at the very least, it will match again to the default value. All right, all of those kind of make rough sense on paper, but we better try them interactively to see if that we really understand them. Okay, to test things interactively, we will try the second of the testing strategies described in the previous section. We will make an HTML file, and the HTML file will refer to a JavaScript file. We'll put the function definitions in the JavaScript file, but we'll interactively call the functions from Firebug. So this HTML file loads examples.js, and examples.js has the two JavaScript functions shown in the section on if statements. So to recap, flipCoin takes no arguments. You just call flipCoin parentheses. It calls math.random, which returns a decimal number, a floating point number, a double precision number between 0 and 1, 0 inclusive and 1 exclusive. And hopefully, if the JavaScript implementation is correct, it's evenly distributed across 0 and 1. It's just as likely to get any number in that range. And so if I compare to 0.5, half the time it should be less than, and half the time it should be greater than or equal to. So I say if. I put a condition inside that's sometimes true and sometimes false. So it will sometimes return heads and sometimes return tails. Okay, let's try it out. So we'll take the HTML file. We'll load it in a browser. We will launch Firebug. And we will type in a function call, not the function definition. That's in the JavaScript file, the function call. Okay, we got tails, heads, tails, heads, tails, tails, heads, tails. And you can't quite tell from this small amount of testing if it's really 50-50. But if you do a large amount of testing and run it thousands of times, you'll find that it's pretty near to 50-50. And so the random number generator in JavaScript is pretty accurate. It's pretty random. It's pretty evenly distributed across the values. Okay, that was flipCoin. The second example we showed in the section on if statements was max. This one takes two numbers as arguments, and it returns the larger of the two. And if they're tied, it returns the first one, and it's the same thing. So again, inside the if statement, we have a condition, but this time for the condition, we use greater than or equal to. So if the first one is greater than or equal to the second one, it returns the first one. Otherwise, it returns the second one. So I've already loaded the JavaScript file, so now I can call it. Let's say max of 1 and 2. I get 2. Well, what about if I do it in the opposite order? Max of 2 and 1. Do I still get 2? Oh, yes, I do. Well, what about negative numbers? Will it work for that? Let's try it. Yep, still works. What about -2 and -1? Let's make sure that it's not just returning the greater magnitude, but the actual greater value. This should return -1, not -2. Okay, it seems to work. And so this strategy, type your function definitions into the JavaScript file, reload the HTML page, but put the function calls interactively into JavaScript, into the JavaScript console of Firebug or Google Chrome, is a good development strategy. All right, before I move on to the switch example, I want to go back and revisit the brief comment I made, which is JavaScript has a funny definition of false. So let's write a new function where we pass in a value, and it just tests that value to see whether it passes. If it passes, it says yes. If it fails, it says no. Okay, and some of these will be obvious. So if I go back to Firebug and I say test if 4 is less than 5, then it will say yes, 4 is less than 5. And if I say test if 5 is less than 4, it'll say no, 5 is not less than 4. So if the value inside is false, it says no. But there are several other things that are considered to be false in JavaScript. Obviously, the value false. And in particular, if I type 5 less than 4, it actually returns false. So true and false are actually explicit values in the JavaScript language. But there's also a funny value called null. It's not used very often, but it shows up once in a while. And if I say test null, it's not a syntax error like it is in some languages. Null is considered to fail the test. It's considered another version of false. So it says no. Undefined. Remember, if I assign to a variable, the return value of the assignment is undefined. If I say undefined here, it says no. It's not a syntax error. You can pass undefined to an if statement. You can even pass in an empty string. And for some odd reason in JavaScript, an empty string is considered to be false. So it says no. 0 is also considered to be false. And then there's this odd construct in JavaScript where if you take 0 divided by 0, it returns this little funny thing, which is short for not a number. In other words, if you divide 0 by 0, well, what do you get? It's not 0, it's not 1, it's not infinity, it's not negative infinity, it's just kind of not a number. And so many languages have this idea of not a number, something that you can assign to a variable, but it doesn't have a real value. And it's called not a number. And so if I say test of 0 divided by 0, it says no. So false is false. Null is false in an if statement. Undefined is false in an if statement. An empty string is undefined in an if statement. 0 is false in an if statement. And not a number is false in an if statement. And anything else is considered to be true. So normally, inside the conditional, you put a real Boolean value, like 4 is less than 5. But it's perfectly legal to just put a number. Test 4. Well, 4 is not false, it's not null, it's not undefined, it's not an empty string, it's not 0, and it's not a number, so it passes and says yes. I can put a string in here. Hello. Well, that's not an empty string, so it passes and it says yes. It's a little bit odd. You can even put the string false. Well, that's a string. It's not the value false. It's not an empty string, so it says yes. So that's all a little bit confusing, but advanced JavaScript programmers make use of this sometimes. But normally, in an if statement, in parentheses here, you put something that's actually a Boolean, a yes or no, a true or false value, like is it equal to this? Is it not equal to this? Is it less than this? Is it greater than this? And so forth. All right, let's go now and revisit the switch example that was shown in the slides. So you pass in a number, and it basically says, if the number is 0, set this variable to Sunday. Don't forget the break, though. If the value is 1, set it to Monday, 2, 3, 4, 5, 6, and so forth. But if the value is something else, what if you pass in negative 38, or what if you pass in 129? I'll set it to invalid day, and then I'll return that local variable. Notice I used var here. If you introduce a local variable inside of a function, as opposed to the parameter to the function, make sure you declare it with var. If you don't, it will accidentally become a global variable rather than a variable local to the function. All right, so let's try this out. Day name 0. Hopefully I should get Sunday. 1, 2, 6 should be Saturday. But 7, I didn't define my day numbers to be from 1 to 7. I defined them to be from 0 to 6. So 7 should be an illegal name. And negative 453 should also be illegal. This illustrates a point, which is when you are testing your functions, pass in the expected good values, but also pass in bad values to make sure that your function can both handle legal values and illegal values. All right, finally, let's go back and revisit the 3 constructs we mentioned at the very end of the if section: the double ampersand, the double vertical bar, and the exclamation point, which mean and not. So if I say 4 is less than 5 and 4 is less than 6, and of course, normally do this with variables, so you don't know the value ahead of time, it'll say true. Both are true. But the key point with the ampersand is if the first one evaluates to false, it never even checks the second one. Because if any piece of an and is false, the whole and is false. And with a or, if the first one is true, if 4 is less than 5, it never even checks the second one. Okay, so for the and, if the first one is false, it doesn't check the second one. For an or, if the first one is true, it never even checks the second one. Finally, the exclamation point is not. It just flips it around. So if I say 4 less than 5, that's true. If I say not, don't put the not in front of the 4, put the not in front of the whole thing, so use parentheses, it's false. And 5 is less than 4, of course, is false. If I put a not, put parentheses around the whole thing, then it's true. Okay, so double ampersand means and, but it does short circuit evaluation. If the first thing is false, it doesn't check the second one. Double vertical bar is or, but it does short circuit evaluation. If the first one is true, it never checks the second one. And an exclamation point means not. It flips a Boolean value. If it was true before, it's now false. If it was false before, it's now true.